point 4, we're going to talk about two very important ideas in calculus and their connection. Differentiability means you can find a derivative. So differentiability just means the function has a derivative at all of its points. And then continuity, which we've been talking about for a while, we know what continuous means. No jumps, holes, gaps, asymptotes, those kinds of things. There is a connection between the two. Okay, and it's this very first thing right here, and then the theorem underneath is a little bit more technical. A function is not differentiable, so we cannot find a derivative at any point where there is a sharp turn or vertical tangent line. So vertical tangent lines, big no-nos. Can't have any different derivatives there because vertical tangent lines have no slope. And a derivative really just represents slope of a tangent line. So if a tangent line has no slope, it would make sense that there is no derivative at that point. And the sharp turns, I'll show you what I mean by those when we graph some functions in the next slide. So the theorem about differentiability and continuity is this. Simply, differentiability implies continuity. If you can find a derivative at every single point, then it is continuous. Okay, so the summary down here, if a function is differentiable at some point x equals c, then it's also continuous. So that's why we say differentiability implies continuity. Okay, however, the opposite is not true. Just because a function is continuous at a c value does not mean it is differentiable. So we can have continuous functions that do not have derivatives at certain points. And again, we'll see those here very soon. So it is important to remember that differentiability implies continuity, but not the opposite of that. Okay, the answers are already here, so we can actually just talk about them. So let's talk about this sort of rational function off to the upper right-hand corner here. There is an asymptote that I sketched in when I was answering these questions. We see it's nice and smooth everywhere except where that asymptote is. So obviously an asymptote is a discontinuity, so we would say it's continuous from negative infinity to 3 and 3 to infinity. And calculus uses interval notation for all of our intervals. You want to get used to that. If you're not already coming out of pre-calculus understanding interval notation, please let me know in class and we'll talk about it a little bit more. But it is important that you know when to use parentheses, when to use those hard brackets. So let me know if you have questions on that. And this one happens to be differentiable, this function, everywhere that it is continuous as well. So everywhere along each branch of this really smooth looking function, we could have tangent lines. So everywhere along this graph, you see it's just very nice and smooth, no holes, gaps, jumps, or anything like that. No sharp turns. So that one, continuous and differentiable, same intervals. This one off to the left-hand corner kind of looks like the silhouette of a person with their hands in the air. We have two sharp points. I did not mean to erase them. Two sharp points, one there, okay? But it is a continuous function. Those things aren't holes, right? Those aren't holes. I didn't cover anything up there. So it's nice and smooth until it hits the x-axis and bounces off, and then hits it and bounces off again. So it is continuous everywhere. Not a problem there. But it is not differentiable at these very sharp turns. Okay, our tangent lines could be vertical there, and that's a big no-no for differentiability. So we would say that it is differentiable everywhere except the points of negative 3 and 3. So in interval notation, we have to write it negative 3, or negative infinity to negative 3, and then that's the union, and negative 3 to 3, and 3 to infinity. So we just have to exclude those x values of negative 3 and 3. Okay, the next function that kind of looks like the way I draw all my birds in art class has another sharp point there, but it is a continuous everywhere function, right? I can draw that whole thing without lifting up my pencil for any particular reason, so it is continuous everywhere, negative infinity to infinity, and differentiable everywhere except this one little point. Again, our tangent line could very easily be vertical there, so not differentiable. Okay, here's some more graphs, super fun things. Left-hand side, we have another rational function. It actually has two vertical asymptotes in it, so it's continuous everywhere except where those vertical asymptotes are, and you can see those intervals. Differentiable the same places. Okay, upper right-hand corner, it's a radical function, sorry. So radical functions are continuous over their entire domain. So this one happens to start at the x value of 1 and continue to infinity. Notice I did put a hard bracket there because the function value actually can equal 1, or we can plug in x to the function, not a problem. But notice the difference, differentiable only from 1 to infinity, not including 1. That's a softer parenthesis there. So we cannot include 1. It's not differentiable there. The tangent line is actually a vertical tangent line there. Okay, and of course, talking about tangent lines, we're talking about lines that hit the graph only once. So it just means I can, over here, like sketching that tangent line anywhere along the graph. Okay. And the last one is continuous everywhere except where it has this jump, so maybe that is a closed circle and an open circle up there. We don't really know how I typed that into Desmos, but continuous everywhere on the left, everywhere on the right just has that discontinuity at 0, so it's differentiable everywhere as well except at that 0. Okay, so not super difficult, just keep in mind where those vertical asymptotes and jumps and sharp points are. So if you were going to wrap up today's lesson in 15 words or less, functions are not differentiable at sharp points or gaps, but everywhere else. Okay, and of course gaps are asymptotes as well. So that's kind of the short version, but talking about those graphs, super important.